See, this is a question today how to prepare for your JEE Mains exam. And the second is the important point here is that what type of formula are you going to use? So, first of all, you read the question carefully. A body of mass 1 kg falls freely from a height of 100 meter. And another important point I'm going to tell you that I'm not going to solve the questions. I'm not going to solve it, but I will give you only the theories. Today I will give you the theory how to solve a problem, what are the formulas are going to be used, and why we are going to use such formulas. So a body of mass 1 kg falls freely from a height of 100 meter on a platform of mass 3 kg which is mounted on a spring having spring constant this much, having spring constant this. That means here a body, this is of mass 1 kg, it falls freely from a height of 100 meter, and we on a platform, this is a platform, it falls here on a platform, and which is mounted on a spring. This platform is mounted on a spring, and which is of spring constant k, it is given to you. The body sticks to the platform. When it falls here, it sticks to the platform, and spring's maximum compression is found to be, this means here this is the spring, and the maximum compression it has been found to be x. So we have to find the value of x. So here you see that how I'm going to solve it. So when the body falls freely, it is means this is a free falling body. The first concept is that it is a free falling body. Free falling body. The first concept, free falling body. So what is its final velocity? Means when it is just about to touch the platform, when it is just about to touch the platform, what is its final velocity? Your final velocity will be equal to root 2gh. This will be your final velocity. Now, again, when the body sticks to the platform, this means after when it strikes the platform, the this body and the platform they moves together. So here comes our collision theory. So here comes our collision theory. Collision theory. Collision theory. See, here comes up here about collision theory. Because it, it has been nothing given to you whether it is an elastic collision or not. So it will be better that we go for conservation of momentum. Then we go for conservation of momentum. Conservation of momentum. Then we go for conservation of momentum. So from conservation of momentum, let this velocity be v1, v. So from this conservation of momentum, that is m1 v1 is equal to m1 plus m2. Let this be v, m2 into v1. Here, this is we get the from here we get the from conservation of we will take the help of conservation of momentum and we'll find the value of v1. That means both the body and the platforms moves together. Then what is its final velocity? We will find it this. So from here we are going to get m1v by m1 plus m2. We are going to get the velocity v1. That means this is the velocity v1. That is, it is the velocity with which this both are moving together. And to find this x, we will go for here your M1, your M1 is 1 kg, and your M2 is your 3 kg. So now the fifth, how you will find this X. So your fifth will be here. That is your work energy theorem. That means here you have done some work, and that work has been converted into your kinetic energy. This means work. It has fallen through a height h, through this height 100 meter. So it has done some work, and this work is the potential energy. So here, last first we'll go for conservation of that is work energy theorem. We'll go for work energy theorem. That will we go for work energy theorem. We will go for work energy theorem. So work energy theorem, we know that the work done is equal to the change in kinetic energy. So here the work done is the potential energy. Here it is the work done is the potential energy of the spring. Here the work done is the potential energy of the spring. So here that means half k x square is equal to your change in kinetic energy. That means this is equal to half k x square. That is your change in kinetic energy here. By the help of this change in kinetic energy, by the help of this we can find the value of x. So I'm not, so I have already told you that I'm not going to do the calculation. Only I want to show you the how to solve this question, and what are the theories lying behind here to solve this question, and how to proceed. So here you see that since this is a ball falling freely, this is a free falling body, and for free falling body, his final velocity, that is when it is just about to strike the platform, what will be its final velocity? We'll calculate by the help of this g. Here your h is equal to 100 meter. Your h is equal to 100 meter, and then we will go for the collision theory. And since here it is nothing given about your about this whether it is an elastic collision or not, it is not given to you. So we will go for the conservation of momentum, and from this conservation of momentum we will find the value of v1. So after that, here the work done, here this work done means work done on the spring, that is the work done on the spring, that is it is nothing but it is the potential energy of the spring, and is equal to change in kinetic energy, by the help of which we can find the value of x. So uh, before solving it, you read the question carefully, uh, and make the picture in your mind, make a clear picture in your mind so that you can solve it. Now here you see a spray gun is shown in the figure. That means the spray gun where a piston pushes air out of a nozzle. A thin tube of uniform cross section is connected to the nozzle. That means your figure is somewhat like this. Here this cylinder and a piston, and from here this the other end of the tube is in a thin tube of is connected to the nozzle. This here it is connected to here, this nozzle, say connected to a nozzle. The other end of the tube is in a small liquid containing container. Here is the container. Uh, as the piston pushes air through the nozzle and it is sprayed out. When we push this air, this liquid is sprayed out. The upper end of the container is open to the atmosphere. This container, which is containing the liquid, it is open to the atmosphere. Now, if the piston is pushed at a speed this, the air comes out of the nozzle with a speed of, we have to find out if the density of the air is rho A and that of the liquid is rho L, then for a given piston speed, the rate, that is volume per unit time at which the liquid will be proportional to. So here again, see what are the theories comes behind it. So uh, uh, small container, as the piston pushes the air through the nozzle, that means as the piston pushes here through, as the piston compression takes place, so here the air moves with a velocity, with a high velocity. Because the air moves with a high velocity here, because the air moves with a high velocity, what do we find here? That is the continuity equation. That is the continuity equation. Continuity equation, that is A1 V1 is equal to A2 V2. So here what happens, here your cross sectional area is small, so here your velocity of the air will rise. Here velocity, as the velocity of the air will rise here, so there will rise here, there will be a drop in pressure. As the velocity will rise here, there will be a drop in pressure, and this drop in pressure will create a suction, and this, because of this suction, the liquid will be lifted up and the liquid will be sprayed out. So first of all, you see there is the first, that is the continuity equation. From here, when we compress the air, so here your this area decreases. So from continuity equation, here your velocity increases. And since your velocity increases, if you take the help of Bernoulli equation from this point and this point, if we take the Bernoulli equation for these 2 points, from this point and this point, if we take the Bernoulli equation, we will find that there will be a drop in pressure. Now, second, if you take the Bernoulli's equation, Bernoulli's equation, Bernoulli's equation for this point 1 and this point, for these 2 points, you will find that there is a drop in pressure. You will find that there is a drop in pressure. Drop, DROP. There is a drop in pressure. Drop in pressure. There is a drop in pressure. So here, see, the theories in lying behind it. Because of this continuity equation, here the velocity increases. That means the velocity of the air increases. And by help of the Bernoulli equation, between, if we take between these 2 points, we'll find that there is a drop in pressure. And because of this drop in pressure, what will happen, that the suction will be created. Because of this drop in pressure, that is the suction will be created because of drop in pressure. That means decrease in pressure, decrease in, because of decrease in pressure. Because of decrease in pressure, there will be suction created here at this point. There will be suction. There will be suction, and the liquid will be lifted up, and this liquid will move out of the nozzle. That means Due to this drop in pressure, there is a kinetic uh, energy, and because of this kinetic energy, that means the uh, liquid is sprayed out. So here your drop in pressure, that is decrease in pressure, here that is delta P, that will be equal to half rho air by V air the whole square. This will be the drop in pressure, and because of this drop in pressure, the kinetic energy, here there comes the kinetic energy of the liquid, because this drop in pressure is equal to the kinetic energy of the liquid, kinetic energy of the liquid. And by the help of this formula, you can find the air coming out of the nozzle with you can find the speed, as well as you can find the volume per unit liquid, you can find it out. So this is the main theory here. So this is a very important question, because this is practically used. You have seen uh, uh, spraying machines, such as which are used in coloring your car. That is by the spray machines you have seen, where when coloring of a car body is done. Here you see that this this is the container which contains the color. Here color, this is the container which contains the color, and this is connected, this is the piston which is connected to a air pressure cylinder. When this pushes here, so here your velocity will increase, and when this velocity increases according to continuity equation, so from this Bernoulli's equation you will find that there is a drop in pressure, decrease in pressure, and because of this decrease in pressure there is a suction here, and your color comes out of the this container, and it is sprayed out of the nozzle, and the kinetic energy of the liquid, this color will be this. So this is the, by the help of this is the theory which is used. You have seen that a person coloring the body of a car. So your uh, the instrument is, it is the instrument uses, this is the instrument here they use. uh, this is the cylinder, and the color is this is the color container which contains the color, and this is the nozzle, and from the nozzles the liquid spray on the body of the car. Prove that a pipe of to length 2L open at both the end. That means both the end. It is an open pipe. Open pipe. And for open pipe, your fundamental frequency is equal to uh, for open pipe, that is your fundamental frequency of length 2L, fundamental frequency, that is V by 2 into 2L, that is equal to V by 4L. Uh, this is your for open pipe, your fundamental frequency means it, since it is open at both the end. So for a length 2L, it is your fundamental frequency is V, that is the velocity of the sound, by 4L. And another pipe of closed at one end means closed at one end. Closed at one end of length L, your frequency will be V by 4L. So what do we find here, that an open pipe of length 2L, its fundamental frequency, and a closed pipe at one end of length L, its fundamental frequency both are the same. Both are same. Both they are the same. Both are same. You see, practically that means uh, the length of the closer pipe closed at not closer the closed at one end, the length of pipe which is closed at one end of length L, the fundamental frequency produced by it, to get the same fundamental frequency in open pipe, the length must be of 2L. The length must be of 2L. This is the conclusion that you are going to get here. Now, second important point, in open pipe, all harmonics are present. All harmonic are present. But in a pipe closed at one end, closed at one end, only odd harmonics are present. Only odd harmonics are present. So the sound of two pipes will not be identical. So the sound sound of the two pipes will not be identical. Will not be identical. Identical. Now here means this open pipe or a closed pipe, ultimately they are producing stationary waves. That means the waves has to be reflected. Here the most important point here is that you take this fluid, you have seen a fluid, there's an edge here, like this edge here, and again this, it is open here, this is an open, and this is the closed at one end. It is almost like this fluid, your fluid, it is almost like this. When the air is blown, it strike at this edge. It strike at this edge. When the air is blown, it strike at this edge, and a jet of air is directed upward, which strikes the edge of this portion. This portion, edge of this portion. And when at first, when air is blown, it strikes here, and from here the air in the form of a jet is ejected upward and it strikes the edge of this portion. When the air strike at this portion, the air vibrates. The air starts to vibrate. The air starts to vibrate. And we know that any vibrating object produces sound. Any vibrating object produces sound. So when the jet of air strikes this edge, the air vibrates and produces sound which passes through this column of the pipe, which passes through the column of the pipe, passes through the column of the pipe. Now, next question is that the sound must get reflected, but here you see this is open. So what I want to tell you, a student while studying it, they must think about it, how it the sound gets reflected. We just uh, we just take to granted that since it is given in your book, uh, it produces stationary waves, the sound gets reflected, so it is reflected. But we do not think why. And when you take this as it is, since it is given in your book, it is you should take it to be granted, then you won't find any interest in the in learning it. So how this reflection takes place, how it gets reflected. So here the one which moves straight, it will move straight, but the sound which gets deflected here, the sound which gets deflected here. So according to Newton's third law, there is an to every action there is an equal and opposite reaction. So when it strikes, the sound wave strikes at this edge. When the sound wave strikes at this edge, according to Newton's third law, the sound to every action there is equal and opposite reaction, so it gets reflected in this way. Similarly, the same thing happens here. Same thing happens, it gets reflected. And this is how the sound gets reflected. This is how the sound gets reflected and it produces nodes and antinodes. So this is how a fluid works. So here harmonic, what is your harmonic? Harmonic, it is the uh, lowest pitch, you can say it is the lowest pitch or the fundamental fundamental pitch fundamental pitch which can can be played, which can be played with a given vocal setup or 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 the note of fingering. This harmonic is the lowest pitch or the fundamental pitch which can be played with a given vocal setup. That means the person who sings a song, his vocal setup, his fundamental pitch, that is the lowest pitch which is set up in his vocal cavity, that is called the harmonic. That is called as harmonic. Now the next question is, two identical cylindrical vessels are and kept on the ground and each contains the same liquid of density D. The area of the base is area of the base of both the vessel is S, but the height of the liquid in one vessel is x1 and other is x2. When both cylinders are connected through a pipe of negligible volume, very close to the bottom, the liquid flows from one vessel to other until it comes to the equilibrium at a new height. The change in energy of the system in the process. New height, that means the average height. Your new height will be x1 plus x2 by 2. Your new height will be x1 plus x2 by 2. So that means uh, when the both the height is become same, there is no flow of the liquid. Here, change in energy means here because of this height, there will be loss in potential energy. The second point is that there will be loss in potential energy. Loss in potential energy. So initially, that means your loss in potential energy, that is Ui minus UF minus UF. So initially, your potential energy was Ui, that is mgh, mgh density, uh, mgh, that is density d, into volume. Volume is s x1 by 2 into g plus this for this, ds x2 by 2 into g. The why did I took this? Why did I take x1 by 2 or x2 by 2? Here comes the theory center of mass. Here comes the theory center of mass. Center of mass. So we will consider the center of mass of this liquid, and the center of the mass will be at a height x1. This will be x1 by 2. The center of mass cm. This height will be x1 by 2. Center of mass. That means you have already studied about center of mass. That is, the whole mass is concentrated at a point. So we are considering the center of mass. So here, so height will be x1 by 2 into g plus this is density into volume. This will be mass. So this is your initial potential energy, and your final potential energy, that will be d as your height will be x1 plus x2 mass, uh, your mass, because we are considering final will because final will be of both these two together. Final will be of both these two together. Here you see there is a slight mistake here, that is slight mistake. That means density into volume, this will be mass, mass GH. So here your density is D and volume is this is your volume of this liquid. So this will be area, this is area as x1, this is your mass, and then G and H will be considered from the center of the mass, that is x1 by 2, and here similarly D as x2, G x2 by G, x2 by 2, x2 by 2, yeah, this. And your final energy, this is your new height, this will be your new height. So your final energy for these two together, 2, this is D, your area will be S, and your height, because they come to the height, both these two, because we are considering these two together. So these two together, so 2 comes here, and height will be this one, area into height, x1 plus x2 by 2 into G, and your H will be considered from the center of mass. So again, x1 plus x2 by 2 by 2. Um, so this will be equal to 2 ds x1 plus x2 by 2 into G into x1 plus x2 by 4, and difference of this you get the change in energy. So here you see that first of all there is a loss in potential energy because there is decrease in height. Because there is decrease in height, so there is loss in potential energy. And the next concept is your new height will be average of these two, where average of these two height. And the third important concept is that when you consider the potential H, for this H you have to consider the center of the mass of this liquid, and at a thus the distance from the center of the mass will be considered as the H. So here center of the mass, and because there is a decrease in height, so there is loss in potential energy. So this is the basic concept which has been used to solve this problem. So again I am telling you that I have taken this problem to tell you two things about the theory. I'm making the revision of this theory. At the same time, I'm trying to explain you how to solve it. What are the theories behind these questions? Here the question is, a wheel of radius r and mass m is placed at the bottom of a fixed step of height r. That means step. See here, this is a wheel. This is a wheel. Q, the center. This is your R. Now here, a wheel of radius r and mass m is placed at the bottom of a fixed step. This is the step of height r, height of the step. A constant force is continuously applied. Means we are applying on the surface of the wheel, on the surface of the wheel, so that it just climbs the step without slipping. Without slipping. Consider the torque about an axis normal to the plane of the paper passing through the cube. This is the torque you have to consider. This is the torque. That means you know that torque that is equal to R cross F. This is also called moment of a force. So your R and F is in this plane, in this plane, and your torque, direction of the torque is perpendicular to this, and it is given to you that normal to the plane of the paper passing through Q. This is you. This my plane is the torque. So again, a constant force is continuously applied on the surface. So here you see that for this force F1, for this force, your torque will be 0. For this force F1, your torque will be 0. And now you apply this force perpendicular to this. Let this be F2. You are applying continuously. That means again this force is moved means that means when you apply this force continuously, this force for this torque is zero. When you apply this force, what will happen? Uh, Something like this. Say something like this. Something like this. This is your step. So here, this is your Q point, and this is your center. So here you see that this F2 force, this F2 force, here comes, say, this F2 force, and you are applying continuously. This is your F2 force. You are applying continuously, and that means this force like this, and then the force will become like this F2 force, and it will become like this, and then the wheel will move upward. First you apply, that means for this force your torque is zero, that means there will be no rotational effect. And when you apply perpendicular here, then you are applying this force continuously, so this will lift here, and then your force will move in this direction, and your wheel will move upward. So here you see that, here you see one thing here, that this is your radius r. If this makes an angle theta, so this distance will be r uh, theta. So here r cos theta, your this distance, we require this distance. Originally it was in this position, so when it moves in this direction, moves here, that means this was your original, this has moved through an angle theta, this has moved through an angle theta, uh, moved through an angle theta. Here you see this ball has moved through an angle theta. This ball, it has moved, let us take, it has moved through an angle theta. So here this is your weight of this ball, which is acting mg downward, and your force, this force will shift somewhere here, because for this force your torque is zero, so this force will be creating a rotational effect. So when it moves upward, the force will be in upward direction, and because but you are applying continuously, so later on this will become force like this. This will be upward, and later on this force will become like this, and it will move out of this step. So this ball has moved through a distance theta. So moved to a distance theta. So here you see this will be, this angle will be theta. This angle, because it has moved through an angle theta, and the weight will be acting downward. Here weight is acting downward. So, but the weight of the body, this ball will be acting downward, and will be acting downward. Um, so this will be theta. So this value will be r cos theta. This length will be r cos theta. That means you are this is the wheel. this like this. You are applying a force upward because you are applying a force upward. You are applying a force upward, and then the ball has moved, wheel has moved to this position. That means it has rotated through an angle theta. So here this will be r cos theta, this length. So what the practical application? That means if you want to move a wheel on a step, if you apply the force like this, the ball won't move upward. You have to apply the force in this direction, in an upward direction. So in this upward direction, we lift the ball upward, and this it has rotated to an angle theta, rotated to an angle theta. Uh, since your force is applying continuously, that means you lift the ball like this, and then you move the ball in this direction. The wheel moves out of this step. So to lift a wheel, you have to apply the force. This is the practical. This is the practical. That means you have to apply the force in upward direction in order to lift this wheel about this edge, about this edge, about this edge. And if the normal reaction here, if at q, your normal reaction is zero. Remember, if at q your normal reaction is zero, that means there is a slipping effect. That means there is a slipping effect. There is a slipping effect. Slipping effect. Slipping effect. But since it is given that without slipping, so your moment of the force about q, so we have to calculate the moment of the force, that means torque of the force, moment of the force. This will be, this is F2, F2, this distance and this distance will be the same here. This and this distance will be the same, this distance for this F2. So sorry. Your this distance and this distance will be same. So about Q will be F2 into 2r cos theta, and this will rotate in your anti-clockwise direction. Weight will rotate in this in clockwise direction. This anti-clockwise, this clockwise direction, and the wheel moves upward. See, anti-clockwise direction. This is clockwise. This will move the ball in this direction, and this weight will move the ball in this direction, and it will move. Ball will move out of this step. So this will be equal to cos mg into r cos theta. So your torque will be equal to F2 into 2r cos theta minus mg r cos theta. This will be your torque. This will be your torque. So this is a practical application. So if you want to move this wheel out of this step, you have to apply the force in this direction. You have to apply this force in this direction continuously, then this direction, and the ball will move outward. So when the ball moves into this position, your force, this is in the upward force, and it has rotated to theta. The important point here is that if the normal reaction at q is zero, then there is a slipping effect. But since it is given there is no slipping effect, so your torque, moment of the force, that is your, it is better to say, yes, torque. Your torque, that will, the rotational effect, your torque, this will be F2 cos 2r cos theta minus mg r cos theta, and this will move out of this step. Here the question is the image of a small electric bulb fixed on the wall of a room is to be obtained on opposite wall a distance L. Means here this is your image of an electric bulb. This is your electric bulb uh, fixed on the wall of a room is to be obtained on the opposite wall. This is opposite wall, and here distance between them is this wall and the bulb is L. Distance is L. The maximum uh, image we have this image of this bulb must be here on this wall, so that the maximum possible focal length of the lens required is, so here you have kept a lens here, lens here. So this distance is your u, and this distance is your, this distance is your u, and this distance is your v. This distance is your u, v. This distance is v, and distance between them is L. According to sign convention, if you let us consider this x, if you consider this distance x, so this will be L minus x, L minus x. So according to your sign convention, your u will be minus x, and focal length, and this will be positive. So 1 by v minus 1 by u is equal to 1 by f. So this is 1 by L minus x minus 1 by minus x is equal to 1 by f. So this is 1 by L minus x plus 1 by x is equal to 1 by f. So the LCM here will be x, L minus x, x plus L minus x is equal to 1 by f. So here FL will be equal to x, L minus x. So this comes about FL is equal to XL minus x square. So this will be x square minus XL plus FL is equal to 0. This is a quadratic equation. And since your image must be real, image is real, image is real, this is a real image. So b square minus 4ac should be greater than 0. So here your b square minus x minus L square minus 4 into 1 into FL must be greater than equal to 0. So L square is equal to 4 FL uh, greater than equal to this. So uh, L that means 4 FL is less than equal to L square. So 4F is less than equal to L. So F is less than equal to L by 4. So maximum possible for focal length, your maximum possible focal length will be L by. So this is all about for today. So this today I have selected the problems, and I have discussed about the theory, which I am trying my best to revise the theory as well as all the theories which are behind the given problems and how to solve it. So today I have not solved any problem. I have given you the basic concept lying behind each question. This is all for today.